All right, so in this lesson, we will graph quadratic functions given in vertex form. So remember that quadratic functions are, like something to say. It'll be like something like this. It may be more complicated than that, but it'll basically be a different rendition of f of x equals x squared. So like this, remember, this f of x equals x squared is actually the parent function. So this right here is actually the parent quadratic. Which is y equals x squared. So, oh, that looks weird. There it goes. So like if x is 0, 0 times 0 is 0. If x is 1, then 1 times 1 is 1. If x is 2, 2 times 2 is 4. If x is 3, 3 times 3 is 9. So what I basically did is I gave you these different versions of it. So this one I took x and I added 3 and then I squared it. This one I took x, I subtracted 3 and then I squared it. And I wanted you to see what happened to it. So like we start here from the same perspective. It's like the same size, right? But in this one we moved left. And in this one we moved, let me use a different color. We moved left. And this one we moved to the right. See? Left, right. Left, right. So the thing is, if h is positive, so if this number right here, so this is vertex form, f of x equals a times x minus h squared plus k. So this is vertex form. Looks confusing, but you'll get used to it. So if this number right here, if h right here is positive, so let's pretend if h is like 3, then it'll say x minus 3. If h is like 4, it'll say minus 4. So if h is positive, it's going to look negative because it'll say it'll say we're subtracting it. Now if h is negative, like if h is negative 5, it'll say x minus negative 5. If h is like negative 6, it'll say x minus negative 6. But when you take away negative, it'll actually say plus. So it's going to look positive. So basically, that's why when we add, we move left, because that's actually a double negative. That's why when we subtract, we go right, because that was actually a positive. We just took it away. So if you add inside the parentheses, the parabola will move left. If you subtract inside of the parentheses, the parabola will move right. Once again, you see it says plus 3, but we moved left. It says minus 3, but we moved right. That's because if this number right here is positive, it'll look negative. But if it's negative, it'll be double negative, so it'll make it look positive. All right, let's look down here. So parent function again, y equals x squared. But this time we subtracted outside the parentheses, added outside the parentheses. If you notice, we start here, right? But it looks bigger, and this one looks smaller, but it's only because I dragged this whole thing, and I dragged it down. Well, like, I translated it down, like, because of course there's more up here, right? I just moved it down into the frame. And then this I moved up. So this is this letter right here. Let's see what it is. It's K. Yeah, it's K. So that means that this minus 3 is k, and this plus 3 is k. Well, this 3 is k, this 3 is k. But so if k is positive, so let's pretend k is like 5, then it'll say plus 5. If k is like 7, it'll say, oh, I can't really see that. If it's 6, then it'll say like plus 6. It'll look like, if it's positive, it'll look positive. But if it's a negative, so let's say k was negative 3, then it'll say instead of minus 3, well, if k is negative 3, it'll say plus negative 3, which is minus 3. if k is -4, then it'll say plus -4, which is just -4. So if k is negative, it will look negative. So if you add outside of the parentheses, you can tell that you move up. The parabola will move up. But if you subtract outside of the parentheses, the parabola will actually move down. It will translate down. All right, next page. So we have our vertex form again. Fx equals a times x minus h plus k. We've looked at h. We've looked at k. We just need to look at... Ooh, actually, sorry, I forgot something. Forgot this down here. So we have this fx equals a times x minus h squared plus k. So the letters and h and k, if you notice, well, I'm just going to tell you, the h and the k, they will tell you where your vertex is. Remember that this is your vertex here, this is your vertex here, this is your vertex here. So, for instance, this one. Remember that this is the x plus 5. It says plus 5, but remember, this is the opposite of what it looks like. So this actually is -5. And this plus 6 is exactly what it looks like. It's just a regular 6. This is like regular. Oh, sorry about that. Let's go back. So we have our parent. This is our parent again, right? Parent quadratic. There's usually a 1 here, right? Or we can, it's always like hidden, but it's there. Or unseen. But when it's 0.2, you see it got wider. And when it's +2, it got skinnier or narrower. So basically, you look at this. Don't pay attention if it's negative. Don't pay attention if it's negative. Don't pay attention if it's negative or positive. It's just that it's less than 1. So if that number is less than 1, if it has absolute value less than 1, the parabola will be wider than the parent. Okay? But if it's, you see this number, you see how it's bigger than 1 because it's 2. So if the absolute value is bigger than 1, remember we ignore the negative, then the parabola will be narrower, skinnier than the original, than the parent. And I can show you right here some examples. Like this is still 0.2, this is still 2. Even though it's flipped, like it's upside down, it's still just as wide. Like these are just as wide. It's hard to see, but this one is just as wide as down here. This one is just as wide as down here. It's just flipped. So if A is positive, so if this number here is positive, which those aren't, but we can tell if they're positive, then it opens up, up, up. If it's a negative number, oh, yeah, well, that's not negative. Negative, negative. Then it opens downward. So if A is positive, like this one was +1, it opens upwards. If A is negative, like that one or that one, it opens downwards.